So I thought that would be kind of nice for y'all. I just didn't feel like I wasn't going to squeeze it in. And as long as you know how to do 8.1, 8.2, and 9.1, then if you go into another statistics class and they start talking about these things before they go into hypothesis testing, then you'll at least know those things right there. So, so you don't have any questions. The final exam will cover, I mean, not the final exam, the last test, which will be, is it called Unit 3 test or Unit 4 test? Unit 4? Unit 4 test will cover 8.1, 8.2, and 9.1, and you have until the 28th to do that, and you have until the 28th to do the final. So technically, after today, you only have 2 assignments, and that is the last test, which is Unit 4 test, and the final exam. Technically, after tonight at midnight, that's the only 2 assignments you have left. So, anyway, there's that. And I'll show that again to all of the class today. So it's really sad that I have to show a piece of paper 2 weeks in a row. It's really sad. So, anyway, let me pull up my handy dandy email. There it is, 120. Now, there's a couple of these questions that I'm just going to hit the highlights because they're not test questions, they're just homework questions. I'm not going to spend a lot of time on the Philadelphia lawyer questions. I'm not going to spend a lot of time on that because 9.1 questions are more important than the Philadelphia lawyer questions. So what I'm going to do is I'm going to pull up the question, tell you what kind of question it's going to be, whether it's a test question but I can tell you right now, these 8.1 questions, 8.2 questions, they're very wordy, and I don't like those questions unless they're short and sweet. Okay, so the first one is, okay, this one is not too bad. It says determine mu sub x and sigma of x bar. That means you got to do your new sigma from the given parameters of the population and sample size. So write that down. This one is a test question because it's kind of short and sweet. Now remember, 8.1, you're told to get p hat. Let me get my marker. Let me get my visualizer. You're told to get p hat, and of course p hat and q hat. And the only other formula that you're given is the formula for your new standard deviation based on x bar. And that's going to be, oh gosh, is it NP over, I can't remember now, NP or PQ over the square root of n, I believe it is. PQ over the square root of n. Or is it sigma? Sigma over the square root of n. No, it's sigma. Sigma over the square root of n. And that is your new sigma, and it's usually going to be the denominator for your new z-score. Okay? Remember me telling you the difference between 7 and 8? 7, in chapter 7, they gave you mu is equal to 25 and standard deviation of 5. And they want to know the z-score at 32. So then you would type in 32 minus 25 over 5. And what is 32 minus, that'd be 7 over 5. Multiply by 2, that'd be 1.4. Okay, that was chapter 7. And then they said, what if? So in chapter 8, 8.1, they're saying, what if you had a random sample of 10, what would the probability be then? Well, now you have to do 32 minus 25, and instead of 5, you're going to do 5 over the square root of 10. I want to highlight that because that is what you're doing right here. That right there is what you're doing right here, and it's called the sigma dependent upon x bar. So in this case, your sigma is 9 over the square root of 9, which is equal to, I'm sorry, the square root of 81, which is equal to 9 over 9, which is equal to 1. So mu is equal to whatever they gave you for 75, and sigma sub x bar is equal to 1. So this is 8.1.9, the homework question we just did. Okay. Now, I did this several times in the homework, I mean in the class, didn't I? The difference between 7 and 8.1, didn't I?
Yes, sir.
You can leave your microphone open if you want to. What did you say? We did go over that? The difference between 7 and 8?
Yes, sir.
I thought we did. So that should be your answer. So mu is 75. And your mu sigma is 1. So that's a test question from 8.1. Why is it a test question? Because it's short and sweet. Okay, 8.2, 18/7. This is one of those that I'm not going to put on the test because it's just too much. It's okay for a homework question, but it's just too much for a test question. Now, there are some good points in it. According to a survey in a country, 29% of adults do not own a credit card. Well, right there, I don't care what the question's asking. P hat is equal to what? P hat is equal to 0.29. Therefore, Q hat is equal to what? 0.71. Suppose a simple random sample of 600 adults is obtained. Random sample of 600 adults is obtained. Complete parts A through B. Okay, so what's P hat? P hat is 0.29, so there's that. Now it's saying determine the standard deviation of the sampling of P hat. So that means I'm going to put, remember 8.2, we've got an 8.2, not only do we have P hat and Q hat, but we've got the formula of the standard deviation according to P hat is equal to NP over, I done forgot it, over N. No, PQ, sorry. PQ over N, and is that the square root? Isn't it the square root? I can't remember. I think it's PQ over N square root. And that's going to be 0.29. I need you to calculate this for me. 0.71 over 600 and take the square root of that number. What do you get? Let me see if I can do it on my calculator. Okay, 0.29. What?
I might have done that wrong. Give me just a second. I'm gonna double check it.
divided by 600, and then take the square root. So I'm going to raise that to the 0.5 power. 0.019. Actually 0.0185, which they say round to 3 digit, 0.019. It should be 0.019. And that's your new sigma. Yep, there it is. Now, this right here says, okay, you're going back to chapter 7. What does it say? What is the probability? I'm going to put B right here. Okay. What is the probability that a random sample of 600 adults or more than 32%? Up, we got to draw a picture. Okay. So I'm going to draw a picture. And my mean, okay, we don't have a mean. Let it give us a mean. Yeah, the 0.29. So 0.29. And our standard deviation is, did they give us a standard deviation? I don't think, did they? I don't think we did. Yeah, so we got to use the 0.01. I'm going to say 2 cents instead of 0.019 because I'm not going to try to do that in my head. So I'm going to say 2 cents. I'm going to say the standard deviation is 2 cents. So that's going to be 29 plus 2 is 31. 31 plus 2 is 33. 35. I hope you understand what I'm talking about. I don't want to, that 0.019, I'm not going to do that in my head. So I'm just going to round it to 2 cents. So that's going to be 0.27, 0.25, 0.23. I think I did the math right. And they're asking, what is the probability of 600? Now, the difference between chapter 7 and chapter 8.2 is chapter 7 would have just said, you know, they wouldn't have said 600 adults. They would have said, what is the probability of being 0.32 or more? And they would have gave you, and you just did the z-score. But in this case, you got to use this as a standard deviation, and you're going to calculate it. So anyway, here is 0.32. So I'm going to use a different color. I'm going to use 32 right there. 0.32. And they want to know, there we go. So now you're going to use this for your sigma instead of your regular sigma. So that's going to be 32 minus 0.29 over 0.019. So I'm going to take my handy dandy calculator. Oh me, I have to unlock it. Oh my, oh. Okay, I'm going to take clear 0.32 minus 0.29 is 0.03 divided by 0.019. That gives us a z-score of 1.58. 1.58, which looks right because this is 0, this is 1, this is 2, so that looks about right. So I'm going to go from 1.58 to 9999 with my normal CDF. So let me pull up my normal CDF, which will take me a minute because I don't have my calculator pulled up. Takes a minute for this calculator to pull up. Come on, you can do it. So I'm going to hit normal, second bars, normal CDF. Now, if I have a new calculator, I'm going to do 0.32. So I'm going to do it. I'm going to do it for you. 0.32 and 9999. Mu is 0.29. And standard deviation is 0.0, what did I say, 0.019? 0.019. And hit enter. And this is new calculator. This is what you would punch in your new calculator. And I've got 0.0572. 0.0572. Now, if you have an older calculator, I'm trying to get all this in one. Move it down just a little bit more. There we go. So if you have a new calculator, okay, it's not going to let me do that. So I'm going to, hold on a second. So if you have a new calculator or an older calculator, you're going to type in second bars, normal CDF, and it may not even ask you this. It may just give you parentheses, and you type in 1.58 to 9999. And it's already got, you don't have to type in, you just have parentheses, and you would type in parentheses 1.58 comma 9999. You don't have all this. So hit paste, and it should be the same answer. 0.0571. 0.0571. So I'm going to put 0.0571, and there should be a tolerance in your homework for 0.0001 plus or minus. Usually those questions are pretty good about putting in a tolerance. So now let's see what else they ask. Well, I think they asked another question. Now, these are good questions. These are good questions as homework, as test questions, but I just wouldn't give you all of them. So this is a good test question. That's a good test question. This is a good test question. But all of them together, that's just too much. So this is 6%. So if 100 random samples of 600 or blah, 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 one would expect 6 because 6% of 100 is 6. Blah, 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 blah. What is the probability that in a random sample, 27 and 32 between, so pull out your handy dandy picture, and now we're going to do in a different color, we're going to do 27 and 32. Well, there's 27, and we already have 32, so we already got that z-score. So all we got to do is find the z-score for 27 if you have an old calculator. So 0.27 minus 29 over 0.019. And if you would calculate that for me, I'd appreciate it. It's going to be around -1 something.
Okay, I got that wrong. You said 0.27 minus 29.
Yeah, down here at the bottom, right here. Minus 0.29 over 0.019. It should be around -1.
Sorry, I'm really slow with the calculator.
That's all right. You're just a disappointment. Are you taking math next semester?
I think this is the last math class I need.
What's your major?
I want to go into nursing.
I would suggest the 103 because
103?
all the nursing students take 120 and 103. I don't teach it next semester, but in the future you might want to take it with me. I probably teach it in the fall next year. You might want to take it with me. It's the same thing as this one. It's just a little bit, got a little bit of business math and a little bit of algebra in it. A lot
For some reason, I'm getting -14.
I'm sorry, what'd you get?
I'm getting -14.99.
No, I don't think that's right. Let me do it in my calculator. You're such a disappointment. So let's go.
I know, I'm working on it.
0.27 minus 0.29. Somebody yesterday got I remember that. Somebody got 14 yesterday. I don't think that's right. Because what does my picture say? My picture says what? -1.
Oh, there we go. I got it. -1.019.
There we go. -1.05. -1.05. So now we're going to type in our handy dandy second bars. Normal normal CDF. And I'm going to go from -1.05, -1.05, oops, 5, delete, 2, we already got 1.58. I do like that, but they didn't make you calculate something else. And I would say it's going to be close to, let's see, what I think it's going to be close to. You know, that's 34 and 34, so that's 68. And then half of 13 is 7. So 7 plus 68 is what? 75? So I'm thinking it's going to be around 0.7500 by the empirical rule. Enter. 0.7961 is your answer. 0.7961 is your answer. So let's pull up the question. And that's the answer, 0.7961. So this is not a test question. This is probably 4 test questions. One right there, find P hat and Q hat. B, what is your probability of 32 or better? Okay, I'm sorry, not P hat and Q hat. Find P hat and sigma P hat, which is the denominator. Remember I told you it's the denominator of your, there it is, of your z-score. That's your denominator based on your 600 random sample. Remember, that's the difference between chapter 7 and chapter 8. And finding an area above and finding the area between. So you got about 4 good test questions there. All right, I think that'll take care. Oh shoot, I hit the wrong button. That should take care of your chapter 8 questions, which are okay questions, but I want to get to chapter 9. And I can't work anything right now. I'm just going all over the place. There we go. And I left my drink on the counter. 120. All right, I'm going to let you write this one down. I'm going to go get my refreshment. Let's see. 9.1 11/4. 9.1 11/4. 9.1 11/4. Oh yeah, this is a good test question. It says determine the point estimate of the population, margin of error, and margin of error for the following confidence interval, and the number of individuals in the sample with specified characteristic. Okay, in this problem, this is just a common sense problem. I'm going to go ahead and write down, here is the confidence interval. They give you the confidence interval. Confidence interval is from 0.095 to 0.345. So you have to find the middle. And I think you can do that with your algebra expertise and finding the midpoint. I think you should be able to find that. All right, now, what is the difference between 35 cents and 10 cents? 25 cents. So that's your distance between both of them. So I'm just going to go to, I want to find the distance. So I'm going to pull up my handy dandy calculator. Clear. 0.345. Well, I can't type. 0.345 minus 0.095. And that's 0.25. So we've got 25 cents between these two, don't we? I mean, does that make sense? Yes or no?
Yes. Yes, sir.
Okay. So if I want to find the middle, I would divide just like midpoint. I would divide that by 2, right? So we got a distance equals 25 cents between these two. So if I divide that by 2, half of 25 cents is 12.5 cents, which is 0.125. Now, 0.125 is my margin of error. Now we just got to find the middle, and we find the middle, which is p hat, which is equal to the middle, by saying 0.345 minus 0.125, or 0.095, or 0.125 minus, plus 0.095. Either way, these two are going to give us 0.345 minus 0.125. And that is our p hat. That's how you find p hat and your margin of error. Your margin of error is just your range divided by 2. That's your margin of error. You put that right here, range divided by 2. And then after you find that, you know that 0.125 is on this side. You add it on this side, and you subtract it on this side. 0.125. So if you do the opposite, if you take 0.345 and minus 0.25, that will give you the middle. If you take 0.095 and add 0.125, that will give you the middle. And the middle is 0.22. And that's how I tell students to find it, because that's the easiest way. This is nothing, there's no probability here. This is all common sense. If you understand midpoint, range, and the middle, then you should understand how to find that. So let's take our handy dandy question. And there's the point estimate, which is p hat, 0.222, or whatever. The margin of error is, what did I say the margin of error was? Margin of error is 0.125, and we feel good about ourselves. The number of individuals in the sample with specified characteristic is what? Well, there's 1,500, and p hat is 22.22, so I'd say 22% of 1,500, if that's what they're asking. I would assume that's what they're asking. So take your handy dandy calculator, times 1,500. I can't stand when I do that. 1,500 equals 330.
That's what I got as well.
That's a good test question because it's short and simple. And they're not asking you a bunch of what color is the sky and what is the address of the guy that attended Wimbledon last year. You know, those crazy questions. (9.111) or 9.127/7. Yeah, here's one of the, I can't stand these questions. A random sample of 100 or 10, 15, blah, 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 blah. Here's, okay, there's p hat right there. So first thing I'm going to do, I'm going to write down p hat. Let me get my, I'm surely not going to look at all that crap. P hat is equal to 534 over 1015. 534 over 1015. So the first thing I'm going to do is find Q hat. So 534 divided by 1015. And that's 0.5261. 0.5261. So therefore Q hat minus 1 is 0.4739. Q hat is equal to 0.4739. Okay, I've got two things that I need. I've got P hat and I've got Q hat. Let's see what else they give us. That televisions are a luxury. They could without or whatever. All right, so do you pretty much think televisions are a necessity or a luxury? And of the 215, 534 indicated that televisions are a luxury. So I'm going to put 52%, they said, are a luxury. So therefore, 49% or 47% said that it is a what? Necessity. How do you say that? How do you spell necessity? It's one C. Necessary and necessity is two words I've never been able to spell. The C and the S is messing me up. Okay, so that takes care of a lot of the stuff in the question. What do they ask for? Look there. They ask for P hat. Boom. Now we got to do the NPQ and all that, and to me that's ridiculous because these are both around 50%, right? Yes or no? Right? They're both around 50%. So let's just say, remember, NPQ has to be greater than 10. Well, what's half of 1,000? What's half of 1,000? I'm asking.
500.
500. And what's half of 500? So yes, it's
250.
I'm not going to sit here and so I wouldn't do 50. I just did 50 in my head. But on this, you have to do 0.526 times 0.437473 times 1,500. And fill out all this stuff. Now, to me, this is just a waste of time. Okay? Yes, check it. Check it in your head. Half of 1,000 is 500. Half of 500 is 250. So just doing it in my head, I got 250. Look at what they got. 253. Okay? So most of these are going to fall. Just write this down because most of them are going to, is stated to be NPQ is, and then multiply NPQ to get that answer, greater than or equal to 2, and the sample size can be assumed. Assume is, that's what I'm telling you. Most of them are going to be less than or equal to 5% of the population. So just write that down because you're going to punch that in. Except for that right there, you're going to punch this in all the same. That's going to change. Okay, so I'm not worried about B. B is just repetition. B, write it down here. And the only thing that's going to change is NPQ. And you're going to do that on your calculator and you're going to change that. That's going to change. The rest of it's not going to change. So C is what I want to get to because C is an actual test question. C says, construct a 95%. So I want you to get your index card because I know you did one. What is your 95% confidence level Z-score?
Give me a second.
I spilled my breakfast drink all over the counter. And this stuff is made out of berries and stuff, so it's probably going to have to use a paper towel so it wouldn't stain the regular towel. What'd you get for 95% confidence level?
The 1.96. What I have written down.
1.96. So I'm going to put that right here. Now remember, 9.1, we got two formulas. One is called margin of error, and that is where you take, oh gosh, help me out here. That's where you take the Z-score, and you multiply the Z-score times, and I done forgot it, I think it's PQ over N, and it might be the square root, I can't remember. Yeah, it is the square root, I think, check it. And N is equal to, I think it's P hat times Q hat times the Z over the margin of error raised to the second power. Check me on those, please. Look in your notes. There should be two formulas in 9.2. So I think I'll take while you're looking, I'll take my red marker. I just need you to check to make sure that I actually wrote down the right stuff. There are the two formulas in 9.1. 9.1 formulas. Well, we'll find out in a second. All right, so Z is 1.96. I guess they want the margin of error. 1.96 times the square root of 0.526 times 0.474 over, what is it, 1,015? So let's calculate that. So 0.526 times 0.474, enter, divided by 1015, raise that to the 0.5 power, and multiply that by 1.96. Oops. Heck. Delete. Second answer times 1.96. Did you get 0.03?
Sorry, I was still looking around in my notes.
That's all right. I think that's it. 0.0307, which is 3%. So we've got a margin of error of 0.03. So let's see what they want. I don't know what they want. Do they want a confidence interval or do they want a margin of error? Yeah. There we are 95% confident. And we got to do a confidence interval. So let's go back to our handy dandy. To get the confidence interval, we got to do a little figuring. Now we know p hat is what? 0.526. So it goes in the middle. 0.526 goes in the middle. And then on this side, we have to add 0.03. And on this side, we have to subtract 0.03. So let's take our handy dandy calculator. So 0.526 plus 0.03, 0.556. And 0.526 minus 0.03. 0.496. And this is your confidence interval. So let's go back to the 0.496 and 0.556. Is it possible that a supermajority, more than 60% of adults, blah, 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 does 60 fit in there? Does 0.60 fit in our interval? Yes or no?
No.
It is possible, but not likely, because it does not contain 0.6. Now, what about the other side? What about this side? Let's pull up our handy dandy. And we're going to do this in peach. What about this? What about these people? What about the confidence interval there? The confidence interval there will be 0.734, 74. We're going to add 0.03, And then we're going to subtract 0.03. So 0.474, 0.474 plus 0.03. I know how to add it in my head, but I'm just doing it. So 0.504 less than Q hat less than, and that's going to be 0.444. So that is your confidence interval for Q hat. .444 and 0.504. Now, I'll tell you what I like about this question. I don't like A through E, but except for B, all of these are test questions. A is a test question, C is a test question, D is a test question, and E is a test question. So you got 4 good test questions in that problem. So if you can do one like number 27, you're good to go for the test, because if you can do A, C, you can do this in your head, because that's not a big deal. Well, you have to do this because you have to do that to get the problem right. You have to do this in your calculator. But if you were just doing this on the test and the question says, is this doable, you would say yes, and you would put 50% of 10, 15 in your head, and you would say yes, it's doable. But anyway, if you can do A, C, D, and E, then you're good to go for the test as far as that material. 9.1, I'm not worried about, some of these are repetitive. So some of these up here. So 9.1, 41/10. I'm not going to go over the same question. If you want to look over the 120/23 yesterday, I did all of these questions. I went over the time, but I did all of them. In a poll, 37 is P hat. Are you in favor of the death penalty? The margin of error was 2%. Here they're going to find N. When they give you margin of error, that means find N. So N is equal to, that's where we take P hat times Q hat and multiply it by the z-score over the margin of error raised to the second power. Now remember, if you are not given, note, if no P hat or Q hat, if they don't give you either one, then you use 0.5 for each, which means that this whole left side here goes to 0.25. Now you got to remember that, because you will have a test question somewhere or homework question somewhere that says, what if you don't have a P hat or Q hat or something to that effect? Then you would use 0.25 for this left side right here. Or you would put 0.5 and 0.5 for P and Q. Whichever one you want to do, it doesn't matter. I just use 0.25. All right, now, let's see what it says. We got P hat, so let's write that down. We always write down P hat. P hat is equal to 0.37. Therefore, Q hat is equal to what? 0.63. What kind of 95% confidence level? Your index card, 95% index card says 1.96. And the margin of error is equal to 0.03. Plug and chug. N is equal to 0.37 times 0.63, parentheses 1.96 divided by 0.03 raised to the second power. And it don't get any easier than that. And yes, this is a test question. So 1.96 divided by 0.03 raised to the second power. And I'm going to multiply that by 0.63, and then I'm going to multiply that by 0.37. And that gives me 994.97, which is 995 people. Of course, if you were more than average, and I would do 1,000 or maybe 1,100. $995. Whoa. Okay, I must have done something wrong. Oh, 2%. Where did I get 3%? Okay, that's going to change. I just did a different problem. Sorry about that. I don't know where I got 3%. So change that 3% to 2%. And check my 95% confidence level. Make sure that's 1.96. So let's go back to the calculator. 1.96 divided by 0.02. And raise that to the second power. And multiply that by 0.37 and 0.63. There we go. 22. I just did two different problems. I gave you a warm-up problem with 3%. So sorry about that. So that's going to be 0.02. And that's going to come out to be 2238.69, 2238.69, which is 2239. Of course, I would probably do 2300 if I was doing it. There we go. Sorry about that. You don't have to erase the other problem. You can just say that 3% was another problem. And that's it. That's a good question because it's short and to the point. 9.17/2. Okay, let me go back. 9.17/2. Let's see if this is a repeat. Nope, it's the easy one. Okay, this is not on your calculator, on your index card, so you're going to have to figure it. And this is how you do it. 85. I'm not going to be able to answer that. 85% confidence level is going to be equal to 0.15 equal to alpha. Alpha over 2 would be 0.0750. So look up inverse norm of 0.0750, and that's going to give us a absolute value z-score. This is what you do when they give you a number that's not on your index card. So I'm going to take my handy dandy calculator and I'm going to say second bars inverse norm 0.0750, and that's going to be left tail. Enter and enter. 1.44. So your z-score at 85 percentile is equal to 1.44. So that is a test question. 1.44. I like those because that's very short and sweet. I think the rest of them are repeats, but we'll go ahead and see. 9.127/7. Yeah, I think we've done one like this one. Yep, we did one like that one. In fact, we did, that was 2 questions ago, I believe. Let's see if this one's a repeat. 41/10. I need to send him a message right quick. In a poll, 69%. Okay, we did the one like this one. Let's find N. So you just plug and chug. 69.69 is your what? P hat. Q hat would be 0.31. Margin of error is 0.05. And what is Z at 94? Look on your index card. What is Z at 94?
I'm checking. 1 second. 1.88.
1.88. So you would plug in those 4 numbers.
Priority 1 message
and
coming in on secured channel.
Didn't know this going to talk. Didn't know this going to talk. Call you later. I don't understand. I'll call him after we get through. Okay, so we already did one like that one. And the last one, 9.137/9. I think we did one like that one too. Wish to be 4 percentage points with 90% confidence. Yeah. Okay, now I want to make a note on this one. We did one like this one. A, we've already done. P hat is 38.38, so therefore Q hat is 0.62. So 0.62 times 0.38 times, give me a 90% Z-score. What's 90%?
Looking on it. It is I do not have that far down.
Okay, so let's do inverse norm. So second bars, inverse norm, and that's going to be 0.05, 0.0500, and enter. $1.645. So if we was to do this one, 1.645 move this down. So 1.645 divided by 0.04, and that's raised to the second power, 0.38 times 0.62, and that is your N at 0.38. Okay, so whatever that comes out to be is fine. But the second one, B, what's the difference between A and B? B, you're not given what? You're not given anything for P hat or Q hat. So you type in this and you do the same thing. And that comes out to be 0.25. And that is what I told you a while ago to watch out for, multiplied by 1.645 over 0.04. So you might want to write that question down as a test question, because B does not give you, he does not use any P hat. Okay, so that's it. I'll go ahead and do 3 for you so you can write down the answer. I'm not going to type it in. I don't feel like typing all that in. Okay, there's your first one. And there's your last one. So if you type in 0.38 and 0.62, you're going to get 399. If you type in 0.5 and 0.5, you're going to get 423. Still doesn't matter, because a good person would do 450 or 500. So you'd have both of them covered. Question, gripe, complaint. Well, it's been nice. It's been interesting, that's for sure.
He sure has.
Okay, I want you to do me a favor. Same thing with the people that's watching this video. I want you to do 2 things with all your teachers. I want you to go in to Rate My Professor and rate all your teachers. Not for me, not for you, for future students. Also, I want you to make sure you look out for the email. They may give you 2 emails. One about how Tri-County Tech did with the coronavirus, and 2, how did your teacher do throughout the semester? Make sure you fill those out too. I don't know if you'll get that other one. I don't know. I don't think, if I was Tri-County, I wouldn't grade us because we sucked. You have teachers that don't even know how to use Blackboard, much less use a video camera. But anyway, make sure you do that, and that's my request for you. If you know, and that's to the students also that are watching this video, for the one student that's watching it. Look me up next semester if you need any help with math or advising. Also for you, since you're taking nursing, I would highly suggest taking that 103, because a lot of nursing students take it together, the 120 and the 103, so that way they have 2 maths for the future if needed. And that's it. Got any questions?
What kind of math is 103?
Actually, the first 2 units of this class is the first 2 units of that class. So if you take me, because I take the probability and statistics and I teach it together, because a lot of my students take 120, they're taking my 103 too. So you don't have to work twice as much, because the same thing that's in 103 for the first 2 units is Unit 1 and Unit 2 in 120. So, and then you got a business, Unit 3 is business math, and then Unit 4 is percentages, scientific notation, that kind of stuff. It's not difficult at all. But I don't teach it during the summer, but I'll probably be teaching one in the fall. So look me up if you're still around.
Sure thing.
All right, I'm going to shut her down, and you have a good afternoon. Good break.
You as well.